Hi, so in this tutorial we're going to be covering retrieving from remote archives. So these archives include, at the moment, the ICOS Carbon Portal and the CEDA archive. So as we did in previous tutorials, we're just going to set up a temporary directory for our OpenGHG object store. And then we'll get started in covering retrieving data from the ICOS Carbon Portal. So at the moment this is done using the retrieve ICOS function, which is part of the OpenGHG.client submodule. And this expects a site code, so a 3-letter site code from the ICOS page. So this is the ICOS map, and this has lots of different sites, Zeppelin on Svalbard and different sites across Europe. But the site we're going to be concentrating on today is Weybourne, which is in the east of the UK. So you can see there the 3-letter site code, WAO. So we'll take this and then we can go back into our notebook and we can import the retrieve ICOS function from OpenGHG.client. And using this function, we can pass in WAO and retrieve the data from the ICOS Carbon Portal. So this will take a few moments to download. So behind the scenes, it's using the ICOS Carbon Portal PyLib library and downloading some additional metadata which describes the data that we've downloaded, which includes instrument data and all that type of thing. And then that returns an obs data object. So if we have a look at the WAO_data object, this is an obs data object containing an X-ray dataset with the number of observations, variability, measurements, quality flag, etc. It also contains the attributes associated with the data and a selection of metadata. So this metadata includes things like the ID from which we've retrieved or a URL which gives us the point at which the data was retrieved from. So this is stored in the metadata, and at any point you can go back and check on the ICOS Carbon Portal the source of the data. So this contains the descriptions of the different variables in the data as well. And so amongst all that metadata are things like the instrument data, so the instrument that was used to take the measurements, and a citation string. So this makes it easier if you want to use this data and then cite it in your work. We can also quickly plot the data. So if you've gone through any of our previous tutorials, you might have come across the plot time series function. So this is just a method on the obs data class. And so this gives us a nice little plotly plot, which you can zoom in. It's a nice little interactive plot. And then you can just double click to zoom out. So that's a nice little plot that covers the data we've retrieved. And now, so that data, ICOS gives different data levels to the data it stores. By default, we retrieve level 2 data. So that's final quality checked ICOS data that's published every now and again. And you can see that data there covers between April 2013 and April 2015. So we've added the capability to retrieve data level 1 or level 1 data. And to do this, you just use the same function, but pass in the data level equals 1 argument. So here we're retrieving data from WAO, retrieving methane data, and that'll go behind the scenes, pull the ICOS data down, retrieve the metadata, and now you can see that we've got more recent data. So from July 2021 up until May this year. So today's the 20th of May, so hopefully we'll have some quite recent data. And similarly, we've got all the attributes set, the different metadata attached. We can also have a look at the data on the Carbon Portal, but do note that level 1 data may not have been quality checked. As we did before, we can make a little plot, and we can see that this is quite recent data. So the most recent data point is from the 19th of May, so 9 o'clock last night. So when we retrieve data, you'll have noticed that it might take a few moments to download the data, it goes away, asks the ICOS Carbon Portal service for the data, pulls it down, and then stores it in the object store. So we cache the data that we've retrieved in the object store. So the second time you want to retrieve it, it doesn't go and ask the ICOS Carbon Portal for the data again. We've stored it. So if you want to retrieve it again, it will pull it back from the cache. So if you want to retrieve data that's newer than that, we can force a retrieval. So if we force the retrieval process and to get more up-to-date data than is stored in the cache, if there's no change, you'll get a note there is no new data to process. But if there is new data, it'll return the new up-to-date data from the ICOS Carbon Portal. So this just speeds up the little process in retrieving the data. If there's nothing new, it gives you what's there. If there's new data, it'll return that for you. So now we move on to retrieving data from the CEDA archive. So the CEDA archive is a commonly used archive of lots of different data. So at the moment we will only pull surface observations data, and at the moment we expect it to be netCDF files that we're retrieving. Now if you try retrieving data from CEDA and you have an issue with it, if you could open an issue on GitHub, that'd be great, and then we can hopefully add support for that type of file that you'd like to retrieve. So to pull data from CEDA, you'll actually need to go to the CEDA data browser and pull the data, retrieve the URL that you want to pull data for. So that's probably the URL of a netCDF file, and you can see here it's taking a little while to load, so we'll just go back into our notebook where we've got one that was prepared earlier, and we'll import the retrieve CEDA function from the OpenGHG.client submodule. And you can see here we're pulling network data from the gauge network, from Heathfield. We're pulling CO2 data down from 100 meter inlet, and it's a netCDF file that we're pulling down. So if we pass that URL into the retrieve CEDA function, it'll go away, ask the CEDA archive for the data, and you can see here this is just a 30 megabyte file, but my internet wasn't the fastest at this time, so it took a little while to download. So that'll take a few moments to download, but once we get that retrieved, we'll have the same type of object as we had before, which is an obsData object, which has data and metadata properties. So you can have a look at the data as we did before. So we've retrieved that data. When we can do anything with it, we can plot a time series graph, we can do whatever we like. So I'll just do that here now. If we want to have a look at the data, we just do hfd.plotTimeSeries, and that should come up. I think there's quite a bit of data there, so it'll take a few moments to plot. And as you've seen before, it's quite a nice, easy way to make a plot, and Plotly makes it very nice to make a nice interactive graph within the Jupyter Notebook. I note that you can save the image, you can make different plots and things, modify the plot using arguments. So as we did before, as I mentioned, it caches what it retrieves. So as you saw there, I retrieved data from Heathfield, CO2 data, and this is exactly the same data as we retrieved earlier, but because it was cached, it doesn't have to go to the CEDA archive, return the data. It just asks the local object store and it returns the data straight away, which massively speeds up the process. So that should make it quite easy to, once you've retrieved the data, pull it down the next time. And as we've done in previous tutorials, I've cleaned up the temporary directory, which removes all of the temporary object store that we created. So thank you very much for watching the tutorial, and please watch out for other tutorials in the future. Thanks.